One part of the 2008 Nobel Prize in Physiology or Medicine went to Professor Harald Zurhausen at the German Cancer Research Center, who sought to understand what causes cervical cancer, the world's second most common cancer among women, with 500,000 affected every year. Against the prevailing view during the 1970s, Professor Zurhausen postulated a role for the human papillomavirus, or HPV, in cervical cancer. He and his colleagues went to identify the primary strains of the virus that carry the disease, HPV types 16 and 18. As part of their research, in 1984, they cloned HPV 16 and 18 from patients with cervical cancer. These virus types were consistently found in about 70% of cervical cancer biopsies throughout the world. Thanks to his discovery, 25 years later, 2 types of vaccines were ultimately developed that provide over 95% protection from the infection. The vaccines also reduce the need for surgery and the global burden of cervical cancer.
Hello and welcome to this special edition of Talk Vietnam. It's a privilege and pleasure for us today to have an exclusive interview with 2008 Nobel laureate in medicine, Professor Harald Zurhausen, who is on a visit in Vietnam for the 4th ASEAN event series Bridges, Dialogues Towards a Culture of Peace, hosted through the International Peace Foundation. Professor Zurhausen will share with us his journey in understanding the causes of cervical cancer. Thanks to his discovery, scientists have created a vaccine that has helped protect millions of women worldwide from the second most common form of cancer. Guten Tag, Mr. Zurhausen.
Guten Tag.
Thanks so much for your time. I know you have a very hectic schedule. How are you today?
Well, I'm perfectly fine. Thank you very much. I had some interesting days behind me, so I'm really enjoyed my stay here.
That's excellent. Is this your first visit to Vietnam?
Indeed, it's my very first visit. I've been in a couple of other Asian countries recently, but in Vietnam I never was before.
How did you find it?
Great. It was really a great experience for me. I spent 2 days in Ho Chi Minh City, and now the last part of my visit here. And so it was really a fantastic experience. What I enjoyed very much was the kindness and the real generosity of the people here. We had some very nice discussions, and there were a number of very nice experiences.
That's great. What made you decide to donate your valuable time to the 4th ASEAN event series, Bridges, Dialogues Towards a Culture of Peace?
Well, when I received the invitation by Mr. Morawitz, it was quite tempting for me to follow. I thought it is a very good idea, although I wasn't really familiar before with the foundation. I thought it was a very good idea to have this foundation, science, as a kind of communicator in this way also for peace. I believe that the exchange of scientific views between nations.
As a Nobel laureate, can you tell me, I'm really curious about this, were you always the top of your class?
No, I was not the top of the class. I grew up in a very difficult period of time because it was the Second World War. I was born in 1936, so when the war broke out, I was 3 years old, and when it ended, I was 9 years old. During this period of time in 1943, in an area where I lived, there was a heavy bombing raids going on, and the schools closed. So for almost 2 years, from 43 to 45, I didn't go to school, almost not to school at all, except for an aunt of mine who was a teacher. She tried for a certain period of time to teach, but in a way my background was very poor when I entered after the war, the high school. And so I really had great difficulties in the first year of high school, but subsequently, of course, then I caught up, and then it was quite much better. No, I was not really the top of the class, but in the, let's say, during the major part of the school time.
Where were you when you received the news that you would be granted the Nobel Prize?
I was in the lab. I was sitting on a computer, not in the lab, I was in my office, in fact, sitting on the computer. It was a 11:15 in the morning, And then, of course, when I heard a Swedish accent on the telephone, for a very short period of time, I thought it must be the right thing right now happening. And I was asked by the secretary of the Nobel Foundation not to talk about it until 11:30, because then there was the official announcement of the Nobel Prize. But I must I must confess that I broke this kind of promise, because I called my wife, and she was already in a plane starting a flight to Buenos Aires in Argentina, and the plane just left the gate, but she didn't switch her cellular phone off, so I could reach her indeed, and the stewardess came and tried to take the phone out of her hands, because she told us she can't use it anymore. But she said, but my husband received the Nobel Prize. And the stewardess was laughing and said, well, I haven't seen anything.
Can you tell me how you felt at that moment?
Well, I was pleased, of course, as probably every scientist would have been. It was quite nice. For my family, it was really great. They were probably much more pleased than I was, and for also for all the friends and for the cancer center, it was clearly a nice day. So the head of the cancer center, the administrative head of the cancer center, organized instantly a big party, which started 2 hours later, and about more than 1,000 people probably were there, so it was quite pleasant.
Dear laureates, on behalf of the Nobel Assembly at the Karolinska Institute, it is my privilege and pleasure to express our warmest congratulations and our deepest admiration as I now ask you to step forward to receive your prizes from the hands of His Majesty the King.
In your banquet speech following the Nobel Prize award ceremony, you mentioned your granddaughter, Hannah, who was 3 years old at that time. She reacted to the news in a very special way. Can you elaborate on that for me?
Yes, of course I wanted to have her with me as well at that occasion, but it didn't work out because my daughter-in-law was expecting another baby 2 weeks later, so she couldn't travel, and Hannah stayed with her. But the parents told her when the news came that this is a very special prize, and somehow they explained that this is something which is rare, and so in a way gradually she became more and more sad and started to weep. And then they asked her, what's the matter, why do you cry? And she said, well, I want to have the Nobel Prize too. So and it was quite nice when I told the story later on to one of my colleagues. He was a moment silent for a while, and then he said, well, he said, your granddaughter probably expressed what every scientist wants to have. He said, with the exception that you don't cry in
That's excellent. Can you please brief us a little bit on your career path? Was it a tough one?
Yes and no. It was tough because for a certain period of time, particularly after we started to work on papillomaviruses, a number of colleagues, my peers in the field, they were not convinced that this is the right track. In fact, there was a lot of discussion on another agent, human herpes simplex virus type 2, that might be the cause of cervical cancer. But we had worked on this agent before, and we couldn't demonstrate any genetic material of this virus in cervical cancer cells. So I was convinced that this is not the right agent to look for. And I'd found a number of reports in the literature that genital warts occasionally convert into malignant tumors, which is rare, but it happens. And about 100 reports over the past century prior to starting to work on this topic. And the idea was then, well, this might be a good candidate for looking at cervical cancer because it may be more carcinogenic at the cervical side in comparison to the external genital sides. That was the reason really to look for papillomaviruses. I've seen in genital warts myself in the electron microscope that they did contain papillomavirus-like particles. I was not the first one to see them. And so, but we started instantly to try to characterize these viruses, which was not easy, but after about 7 years really, we finally achieved this and could isolate the genital wart viruses. We saw then that we were on the wrong track in the sense that these viruses did not cause cervical cancer, but with the aid, in particular 2 of my students had the task to genetically clone related sequences which we found in these in cervical cancer tumors, and they were both quite successful. So soon afterward, in 83 and 84, we came up with HPV 16 and 18, and that really changed the picture completely.
From the time of that meeting to the time when the world realized you'd been quite right, it was a journey of about 10 years?
Well, initially, let's say we started really to work on this quite intensively in 1972, and in 1979, this was 7 years, we finally isolated the first genital papillomavirus, the human papillomavirus type 6, and subsequently with the aid of this virus, a related type 11, and then we had again a little phase of frustration because we didn't find them in cervical cancer with the exception of one biopsy which contained the human papillomavirus type 11. But we saw some faint bands in some of the test systems which we used, and that suggested to us that cervical cancer contains somewhat related agents but not identical ones. And these were the ones where 2 of the students got the task to isolate them, clone them, and to characterize them.
When Professor Zurhausen asserted that the human papillomavirus, which was known to induce skin warts, caused this cancer, not many people believed him. He predicted that the virus existed in different types and changed shapes in tumor cells. He realized that no virus was formed there, but that certain virus genes instead integrated into the cervical cell genomes, thereby giving rise to the cancer over time. It was not possible to culture the viruses, but Zurhausen instead had to prove his hypothesis by using small bits of single-stranded DNA from the actual wart viruses. He used these bits of DNA as bait to be able to attract virus DNA copies, first from genital warts and later also from cervical cancer cells. After more than a decade of persistent work, he isolated different types of human papillomavirus that cause more than 70% of all cervical cancer. Virus genes were present in the DNA of every cancer cell and reprogrammed the cells to grow uncontrollably. His discovery has led to vaccines against these viruses, which offer protection against infections.
After your winning project, what has been the focus of your research?
Well, since in fact, since the year 2001, 2002, I started more intensively to look for additional types of cancers which might be linked to infectious events. So I began to analyze epidemiological data which existed on various types of cancer to see whether they provide any hint for a possible involvement of infectious agents. And one cancer which interests us most and is still interesting us today quite intensively, when I say we, it's a team of my wife, Esther Michelle de Villiers, and myself, is colon cancer. Colon cancer shows striking features in epidemiology, and it's known since quite a long time that there exists a linkage between colon cancer and the consumption of what was called red meat and processed meat, smoked air-dried meat, for instance. from a number of studies which I conducted subsequently, it became quite suggestive for me that it's probably our common cattle, which may carry agents which present a risk for the development of colon cancer, because everywhere in the world where beef, or common cattle, is being consumed at a higher rate, there exists a high rate of colon cancer in India, for instance, where the Hindu population doesn't eat beef at all, has the lowest rate of colon cancer. And so there are a number of similar situations and observations, particularly in Japan and Korea, where after the World War II, 20 years later, the rate of colon cancer was rising rapidly in Korea 20 years after the Korean War. And in both of these countries, there was a lot of introduction of beef meat, and also a lot of consumption of raw or undercooked meat was taking place. So this led to the hypothesis that this is really the undercooked or rare beef which is a risk factor for cancer. Now, this is the reason why we started to analyze, and we are still doing it at this moment, to analyze cattle materials, sera, and also saliva for viruses. And indeed, we have been not very, but in a reasonable way successful, because we could, in the meantime, identify some viruses, and some of those are really identical to those which you can observe in humans. It doesn't prove that they cause cancer, but at this moment it's a good hint that it's worthwhile to look more carefully into this issue and to try to prove their potential role in cancer development, specifically in cancer of the colon. So this is one of the major activities.
That in general we're going to see more links between infectious diseases and cancer in the future?
Yeah, let me say it from the beginning. It's not only viruses, of course, there are also bacteria and parasites which cause cancer, but about 2/3 of the infection-linked cancers are due to viral infections. Indeed, today we have about something like 21% of the global cancer incidence linked to infections, particularly here in this region of the world, in Africa and a couple of other countries. The rate is quite high of infections linked to human cancers. Yes, I think there's a good chance that in the future we will have an increase in cancers linked to infections. If, for instance, what we suspect, cancer of the colon and cancer of the blood system, of the hematopoietic system, would be linked to infectious events, then we come quickly up to 35% of the human cancers linked to infections. So it points to a fact which was ignored for a very long period of time, that infections are really major carcinogens. But one other aspect came up during this period of time, namely that none of the infections is by itself sufficient for cancer induction. Even though the cells pick up the genetic material, for instance, of viruses, this is not sufficient. It may be a necessary factor for cancer development, as in cervical cancer, but it's not sufficient because the same cell has to acquire some changes in its own genetic material at very specific sites. And this explains why there's such a long latency period between infection and the development of cancer, which in some cases moves up to 60 years, 6 decades. So it's very, very long sometimes. And the length of the latency period appears to reflect the number of additional genetic changes which have to occur within an infected cell.
What do you think is the most decisive factor in preventing cancer?
For me, it's clearly the possibility now to prevent cancer. I mean, it's of course good to see at the moment that the death rate on cancer globally is slightly going down, which is an effect of a successful cancer treatment. But we still see at the same time that the incidence, the increase, that we have an increase in the number of cases acquiring cancer every year globally, which is in part due to the age situation of the population during the past decades in Europe, in the States, in some parts of the world, unfortunately not everywhere. The population gets older. We gain per decade approximately 1.5 years of our lifespan. And cancer is mainly, not exclusively, but mainly a disease of elderly people. And so with the increase in lifespan, the cancer rate is increasing. Avoidance of some carcinogenic compounds, avoidance of ultraviolet irradiation by sunlight, for instance. All these factors contribute to the development of specific cancers. But in each of these cases, this requires a change in lifestyle if you wish to avoid these risk factors for cancer. And vaccination, in a way, has a great advantage that it does not require a change in lifestyle. There's some other aspects which came up from the development and the identification of infectious agents in human cancer, namely that we acquire many of these infections which after long periods lead to cancer, and they persist in our body, in our blood stream, for instance. But there are no novel means to treat these infections, even if they exist, like hepatitis C, there are novel developments, AIDS infections, for instance. A couple of others, hepatitis B virus infections and so on, where we can treat these persisting infections. They go down, the levels of the agents go down or disappear even completely. And this is another mode, how we can now think of a kind of a primary prevention of cancer without requiring later on a surgical intervention. So this is, in my opinion, one of the most important progresses which has been made and can be made in the future.
During his visit to Vietnam this time, Professor Harald Thorhausen delivered a keynote speech at the Hanoi University of Medicine before hundreds of Vietnamese doctors, medical lecturers, and students. Let's have a look.
During its 110-year history, this is the first time the Hanoi Medical University has ever received a Nobel laureate in medicine. The auditorium, with a capacity of 500 seats, were quickly filled. In the beginning of his presentation themed Cancer Prevention as a Challenge for Global Health, Professor Harald Thorhausen said that the world was progressing slowly in the reduction of cancer mortality, but had not yet made progress in reducing cancer morbidity.
If you look now into the risk factors which have been identified for colon cancer, there's clearly the prime factors are the consumption of so-called red meat and of processed meat, smoked, air-dried, a couple of other types of preparatory steps which are involved, which elevates the risk after long-time consumption for this type of cancer by 20 to 30%.
Many leading Vietnamese cancer experts attended Professor Thorhausen's presentation. As cancer is becoming a very serious problem in Vietnam, the presentation attracted the attention of all participants. Each year, 150,000 Vietnamese patients are diagnosed with cancer, and more than 75,000 die due to the illness.
Có tới 70% người bệnh đến khám và chữa bệnh ở giai đoạn muộn. Ở đây là cái lý do chính giải thích vì sao cái tỷ lệ chữa khỏi bệnh ung thư của Việt Nam chưa ngang bằng so với các nước. Song song các bệnh truyền nhiễm được từng bước đẩy lùi, thì các bệnh không nhiễm trùng, trong đó ung thư thì đang có xu hướng tăng lên một cách nhanh chóng. Nguyên do thứ nhất là do thuốc lá. Chúng ta biết là ở Việt Nam thì cái tỷ lệ thuốc lá rất cao, khoảng 49 tới 5% ở nam giới và khoảng 2% ở nữ giới. Cái thứ hai là tuổi thọ trung bình của người Việt Nam được tăng lên, mà ung thư thì lại hay mắc ở cái lứa tuổi về sau này. Cái thứ ba là cái dinh dưỡng chưa thực sự hợp lý, kết hợp với một số chất bảo quản thực phẩm mà chúng ta chưa thể kiểm soát hết được.
Professor Zurhausen's presentation inspired the teachers and students of Hanoi Medical University, including Lê Ngọc Bay, a recent graduate who became a medical intern at the Oncology Department of Hanoi-based Bạch Mai Hospital.
Nó là một cái động lực cho chúng em, những cái người mà trẻ và đang rất là có cái tinh thần tìm hiểu. Em rất là muốn là có thể phấn đấu để mà, bởi vì rằng như thầy hiệu trưởng trường em nói thì là nếu mà các bạn muốn có một cái giải Nobel cho trường Đại học Y Hà Nội thì các bạn hãy bắt đầu ngay từ bây giờ. Em cũng rất là mong em và các bạn là những bác sĩ ung thư mới ra trường thì em rất là muốn sau này mình vẫn cũng có thể có những cái công trình nghiên cứu như thế. Một cái nỗ lực rất là lớn.
Qua cái sự kiện giáo sư đến với nhà trường để chúng tôi khuấy động lên cái lòng yêu say mê khoa học của các em sinh viên của nhà trường, và chúng tôi cũng kích thích các em để các em cũng dám nghĩ, dám làm, cũng dám mơ ước đến cái giải Nobel. Bởi vì chúng ta không mơ ước thì không bao giờ chúng ta đạt đến.
In his presentation, Professor Zurhausen also said that the consumption of raw or undercooked red meat, mostly beef, can raise the chance of contracting cancer. White meat, specifically the consumption of fried, grilled or smoked chicken and fish, is considered relatively safe. Changes of lifestyle can help avoid risk factors for cancer development. These changes include giving up on bad habits such as tobacco smoking, no physical exercise, obesity, excessive alcohol consumption, or intensive sun exposure. Another important measure is the primary prevention of cancer by successful treatment of long-lasting infections, for example, hepatitis C or hepatitis B, which is responsible for approximately 80% of liver cancer.
In your presentations before medical lecturers and students in Hanoi as well as Ho Chi Minh City, why did you mention cancer prevention as a challenge for global health?
Because I believe that this is the only way how we can really reduce the global burden of cancer. And the one other reason is that I feel at least that cancer prevention or prevention of diseases in a way is not sufficiently taught at medical students in universities, and even the young doctors, they are more trained to cure patients who acquired already disease, which of course is an important issue, but nevertheless they ignore frequently prevention. And when you look around and when you discuss, for instance, at the moment, of course the papillomavirus vaccine is close to my heart. If you talk to gynecologists and you see from time to time that some of them are not really familiar with the development, that is a bit frustrating, and you need to do more advocacy for these types of preventive measurements in order to reduce the cancer burden. If we would today start to vaccinate globally each young child against hepatitis B virus and high-risk papillomaviruses, we could already prevent at this stage something like 12 to 15% of cancers in females. In males, the rate would be lower.
Can you please quote some of the most frequently asked questions from the public during your lectures?
Well, the most frequently asked questions probably concerns the vaccination against human papillomavirus. Why this vaccination is only active in persons not yet sexually exposed, sexually active. And the second most frequently asked question was clearly the question, why do you propose that boys should be also vaccinated, since they of course do not develop cervical cancer? And I usually answered, if we would only vaccinate boys, we probably would avoid more cervical cancers in women than only vaccinating women. And the reason is that in most societies globally, the males in the age group between 15 and 25 years have usually more partners than females at the same age. So in a way it is important to vaccinate boys, but this is not the only reason. Clearly there are other reasons, because they also have some other cancers which are due to high-risk papillomaviruses at a lower rate as cervical cancer. And of course it may lead to an eradication of these viruses in a global vaccination program in a foreseeable period of time.
Is it absolutely necessary to be vaccinated against cervical cancer?
There's nothing absolutely necessary. If a person, for instance, has only one partner and the other partner had only this one partner, then you wouldn't need a vaccination at all, because there's no risk then to acquire these types of infections. But since, unfortunately, this is not true anywhere in the world, the situation is quite different, and so it's indeed, one should strongly recommend the vaccination for teenage girls and boys in order to avoid this.
What can you say about cervical cancer prevention and treatment in the world today? How effective is it?
Well, the vaccination is quite effective. It's at least against the types which are presently in the vaccine is protective close to 100% of the individuals, at least for time periods, in preventing the precursor lesion of this cancer of up to 9 or 10 years. And it is likely that the vaccine will last for longer periods of time, but this is the only period which is presently covered. I said before that cervical cancer takes 15 to 25 years before it develops after infection, so we don't have statistically significant results yet in the prevention of cervical cancer. As far as cancer, another type of cancer prevention is concerned, of course the pap smear is quite effective in cancer prevention. It leads to the discovery of precursor lesions of this cancer and their surgical removal, which is important. Wherever this is done carefully, 70 to 80% of cervical cancers can be prevented, but it requires, of course, a surgical intervention in order to do this. And it has a disadvantage still that about 20–30% are not discovered under these circumstances. As far as treatment of cervical cancer is concerned, indeed, the standard protocols of treating cervical cancer are either surgery or surgery and radiation or radiation of this type of cancer. They have been fairly successful, but still today about 1/2 of these females who develop cervical cancer die of this disease, and in many parts of the developing world this percentage is higher than 50%. So there is an urgent need indeed to improve also the therapeutic procedures.
During your meeting with the medical lecturers and students in Ho Chi Minh City, you said young talented scientists often found out a way of their own, which sometimes might go opposite to that of their mentors. Did I get it right? Is that what you can you please elaborate on that a little bit?
Right, but what I was saying was basically that frequently what happens is that young scientists, due to the pressure to publish in good journals, are frequently forced, particularly the very talented ones, to join very good groups where they foresee that they can publish well and where they can publish in good journals. And this, in many instances, leads to a program later on in their postdoctoral period and subsequently to follow the paths of their mentors. When I started my own studies in science, for 3 years I came to a laboratory where I didn't get any advice, which was a little bit sad, and at the time I didn't like it at all. But looking at it back retrospectively right now, I think it might have been a good period for me, because you could develop some ideas. Clearly many of them were not realistic at all, and clearly I learned that I couldn't follow them. But in a way I could develop some path which was a little bit out of the mainstream of science, and continued this for quite a long period of time when it was still not in the mainstream of science. Gradually now infections and cancer come into the mainstream as well.
Do you have any specific advice for those young Vietnamese scientists who have also chosen medical research as their lifelong path?
Well, I would say work persistently on an original theme. for longer periods of time. Don't get frustrated so much that you skip it completely. Usually even on some sideways there's some interesting data along. And if you get old enough, and try to get old enough, you may even end up with a Nobel Prize.
During the reception held in your honor, the Vietnamese Minister of Health suggested that she would be grateful for your support in the future. Do you have plans to return to Vietnam for any projects or help the Vietnamese medical students in some way?
I'll tell you, it would be delightful for me to return to Vietnam because I thought it was a very hospitable and beautiful country at the same time. I haven't seen, of course, very much right now due to the visit in 2 cities only, but I certainly would love to see more of the country too, to see some of the historical places who are praised for their beauty, and I'm sure they are beautiful, so it would be quite nice to do it. I do not have any definite plans at this moment, but clearly I would look forward to coming again to this country.
Excellent. So I hope we will see you back. In a developing country like Vietnam, how do you think we should invest in medical studies?
Well, I think a country like Vietnam and many of the Asian countries should invest also to some degree in basic research. They should really, at least, you know, not every country can cover any aspect of science. But I think even for developing countries in Africa or somewhere else in the world, it would be wise, that's at least my opinion, if they concentrate on specific aspects of basic research, try to develop it in an application-oriented way into certain types of directions. So it's also important for the industrial development of the individual countries to do something like this, and also to, in the end, to develop something where they're internationally competitive. I hear frequently arguments that we cannot afford it to finance basic research, so we try to translate research which exists already. I don't believe that this is the right policy, because you cannot rely on data which are obtained somewhere else and collect them. Then they are usually based on a lot of experience in those countries, and they have a much better chance than to progress more rapidly than you can do under those circumstances. So my idea is really there should be some sectors of basic research which need to be supported, just keeping in mind the strengths of the country in certain areas.
What would you say is the sector that Vietnam should focus on?
This is for me a most difficult question because I'm really not so familiar with the details of the activities here in Vietnam. But I could, particularly as far as medical activities are concerned, I could easily see that, of course, you have here some big medical problems, specifically with infectious diseases. Take dengue fever, for instance, or malaria is still a problem here, not such a big problem, but it is a problem, and a couple of other diseases. So it must be a decision made by your health officials, indeed, and I wouldn't dare to interfere with it from my side.
As a scientist, what principles guide you? What or who inspires you most?
Well, principle which should guide a scientist are really that they should be critical. They should be critical even against their own results. If something looks too persuasive, it's frequently wrong in the end. And so one needs to really control carefully the studies. In my lifespan, I've experienced a few cases of attempts of frauds, not so much in my own group, but also as an editor of a journal. I saw that a couple of articles which had been submitted were fraudulent, and so it's not a sincere work which has been conducted. And you start to wonder occasionally how many remain undiscovered if you discover a certain number of them. And but this is, of course, what the other aspects which should characterize a scientist is really an engagement and really the willingness to do something and to contribute something. And also, as I said it before, persistence is another important characteristic, at least from my viewpoint. but I originate from an area in Germany where people are supposed to be a little bit more stubborn and clinching to specific aspects for long periods of time as well.
So what or who would you say inspires you most?
You mean as a person?
It can be a thing as well.
Well, what inspired me as a young person were clearly the reports which I was eagerly reading on some of the great scientists like Robert Koch, Louis Pasteur, and a couple of others. I was eagerly reading those reports, and I really thought that would be a good example for me. Hopefully I could do it similar to them.
That's great. And in all your Nobel speeches, you mentioned your wife and children. What role does your family play in your scientific success?
So, they, unfortunately, during my lifetime, really, particularly when the children were smaller, I was not sufficiently often at home. I was traveling a bit, but on the whole, they tolerated it quite easily, and all of them made their career. They all three are PhDs by now. One is an MD and PhD. And so, in a way, they are quite successful, and I'm proud of them, I must say. I'm also proud of my grandchildren, which there's 3 grandchildren now there. But it's sometimes difficult to combine the family life with the scientific requirements, really. And I guess many scientists feel this the same way as I do.
Thank you so much, Professor Thorhausen, for spending your absolutely valuable time with us today. And it's been an absolute pleasure to talk with you, and good luck with your future endeavors.
Well, thank you very much. Pleasure to talk to you.
And that's all we have for this special edition of Talk Vietnam. I hope you enjoyed it as much as I did. Thank you and goodbye for now.